Okay, I would like to discuss here an interesting thing that it's almost every day in life you use it, and it has a connection with with probability. That is like this: if you have a shop and there's a guy that you sell cakes and maybe some hot food also. You bake it, you get a big roll of cake. The guy asks you, I would like to have 2 pounds of marble cake. So we all know that the lady that's behind the counter, she cuts the cake, she doesn't know exactly how much 2 pounds is. If she's very professional, she knows already how to cut. It will be either a little bit less than 2 pounds or more than 2 pounds. It will be somewhere in the range of 2 pounds. Now, this lady, somebody asks her for 1 pound, then also the same idea. So here's the question: is it if she wants to be very close, the closest possible to 2 pounds? What's better? Should she cut one time and one square rectangle and try to make it as close as possible to 2 pounds, or she should cut separately a pound and then another pound? Now, intuitively, people will say, first of all, what is the difference? And nobody, think a little bit more into it without going into technicalities. We can argue like this: look, if she cuts one shot at 2 pounds the cake, so it might be 2 pounds, it might be 1.95 pounds, or 2.05 pounds. There's a certain error that you can make. Now, if she cuts, however, 1 pound and then another pound, so let's assume the first pound will be, there will be an error. If by 2 pounds, their error can range from 1.95 pounds up to 2.05 pounds. So we can assume that by 1 pound, if you look at in a proportionate method, the error should be from 0.975 till 1.025. That will be the relative error. That should be understood, because if you make an error, then it's a certain percent of how much the real value is meant to be. That you make a certain percent of that error. So it doesn't work with a cake so much. It works with the percent of the full pound. And if we say that by 2 pounds it's 0.05, so by 1 pound it will be 0.025. Okay, here is the catch. So here, when she cuts separately the first pound and then the second pound, there is a possibility that the first pound will be less and the second pound will be more. That will average it out closer to 2 pounds. So, what is this trying to imply? That if she cuts one shot 2 pounds, then there is a nice percent that will be very close to 2 pounds, because it's probably far-fetched. It will be 1.95. It will be probably 1.99, 1.98. It will be, they call it the normal curve. It will be, the bell-shaped curve. that you see in all the pictures and all the doctors have it. So the rule is that the average is the highest, the peak of that curve. So here too, it will be very close to 2 pounds. It's a very small probability, it should be 1.95 to 1.96. Obviously, the highest probability is it should be somewhere between 1.99 and 2.01. Okay. However, when she cuts twice, she cuts the cake for 1 pound and another pound, then even if it goes far from the range of the center, there's still hope that the second time it will be on the other end of the range, and that again will make it be close to the center. So in order to get this down, and this is just very rough talk, let's go down, let's get it down to the mathematical terms. Let's assume first of all what they call uniform distribution. It's not true, but just to make things very simple, let's imagine that it's uniformly distributed between 1.95 and 2.05. That's where, so what's the percent that it should be between 1.99 and 2.01? So we simply, since you know that there's from 1.95 to 2.05 there's 10, this is 2 out of 10, so it's a fifth. It's 20% chance that it should be between 1.99 and 2.01. That's 20%. So actually, if you want to look at it the negative way, there's 80% chance that it should be away from either side, either less than 1.99 or more than 2.01. That is if she cuts it, if she cuts the cake in a simple, in one-time shot. So we only have a 20% chance that it should be the accuracy of 0.01 this side or that side. If she cuts the cake 2 separate times, so the first time she cuts it, so here this is a uniform distribution that must be added. So somebody will ask you, what's the probability that should be between this and this, between the bottom result, the end result should be between 1.99 and 2.01. The way to do this is to add, you take x plus y. X will be the uniform distribution that it's distributed evenly from it's distributed evenly from 0.975 till 1.025. That's one distribution, we'll call that x. And then y will be the same identical uniform distribution. So this I will give in the next video illustration how to do it, how to find. Again, the question is what the probability should be between 1.99 and 2.01. Please look for the next video. Thank you.